Hello, good afternoon, thank you for coming. My name is Dewey Sasser, and I'm going to be talking about infrastructure as code, and specifically how to not end up with the virtual equivalent of this. I am, as it mentions, I'm a consultant, which means I have seen a lot of different code in a lot of different places. I also tend to focus on long-term projects, which means I see the outcome of decisions. So I've developed some kind of strong opinions about what works and what does not work over the years. I'm actually, my background is in development, not operations. Was primarily a distributed systems developer, did build and release stuff, worked for startups, so I was doing DevOps before we knew to call it DevOps. About 7 years ago, I started focusing more and more on the operations, building out some private cloud, and then wandering into public cloud. I'm always interested when somebody's presenting what's the scale we're talking about here. Does this apply to me? So this is basically the scale that this presentation covers. Everything from, we've got one app server, one database, very little load, all the way up to hundreds of virtual servers and more than 10,000 transactions per second. So the tools and techniques I'm talking about here scales very well to both ends of that extreme. Why infrastructure as code? Why don't we just click on things? We've got a lot more complexity now than we did even 10 years ago, and we need to manage that somehow. We want to reduce our deployment risk, and we want to understand the changes before they hit production, because predictability is really key. Is this going to break? How long is the downtime? Will there be downtime? And who in here has a DR requirement? That if something goes wrong, it has to spin up somewhere else? Yeah, infrastructure as code really helps with that. So let me talk a little bit about dev versus ops, because infrastructure as code is really where they start blending. Development, we can make this faster, we can do it better. Hang on, 1 minute, it'll be done. Thank you, tomorrow it'll be done. It's really driven by enthusiasm. They want to make things better, want to add features. Ops is a little bit different. Oh my God, don't break anything. Don't lose the data. Oh, no, do not lose data. It's really driven much more by pessimism, sometimes even a little bit of fear. It's better to not deploy something than to deploy something that breaks. DevOps blends this. So the idea is we know this is going to work because we've done it 50 times already. We can repeat this. We've done it 50 times. And that was just in the last week. And we develop things to make operations easier. And then we operate things to make development easier. Current industry trends, you don't usually have teams that are DevOps and that they they do both at the same time. You usually have some concentration of focus on one side or the other. But the idea is you understand and blend the concerns of the two sides. This gives us confidence in what we're deploying. Infrastructure as code is a little bit different than program code. There's a lot of similarities, but there are some key differences that I'd like to talk about. First, let's talk about the similarities. We control the changes. We build the things outside of the user's view. This is the classic don't develop in production. An application developer builds on their machine, then they give it to you. That's what infrastructure as code allows us to do from the operations side. I'm developing it over here out of your site, and then when it's all ready, I roll it out to you. This way I look good because it doesn't break instead of you see all the mistakes that I made yesterday. You can very definitely have good code and bad code. Not all code is created equal. Some of it is hard to maintain, some of it is easier to maintain. You have to care about that. Operations traditionally are, it works, good enough, back away. That's not true with infrastructure as code. That doesn't work well. That can be better. And there are patterns that work, and there are also patterns that don't work, that cause problems that you have to care about. Now, how is it unlike program code? Programs usually describe how to do something. Infrastructure is usually, as code usually describes what exists. I have a server, I have a database. Behavior is actually something that happens in the what. That's usually what the programs do, and the infrastructure as code describes more about the what than the how. Infrastructure is much more difficult to test than programs because nearly everything is an integration test. When you're writing a program, you do a unit test. You test small things in isolation. I don't need to test Nginx in isolation. I know it works. So I'm testing how it works together with the other things. Makes testing much more difficult. And also, on a related note, it's very hard to isolate these pieces. Again, Nginx works. I don't need to deal with it in isolation. What I care about is how it mixes with the rest of my infrastructure. So, sanity. First of all, what's important in approaching infrastructure as code? I'm sure everybody has heard we need to make progress, start doing something now, please. Infrastructure as code is not about speeding up how fast you get going. It's about speeding up how fast you complete. So yes, it will seem in the early days that it takes a little bit more time, but then you'll be done. And you'll be done while people who are trying to click in a console are still chasing odd bugs and something that worked yesterday can't be repeated. Next thing that's important in infrastructure as code, very much like program code, you need to map your technical concepts, how you think about the problem, how you think about the problem. So I think about it as a web server, an app server, a database. I want to express that as a web server, an app server, a database. I don't express that as an Ubuntu box that happens to be running Nginx. Right? So I want to make these concepts have a very clear relationship so I can manipulate them better and change them better. When you're starting off with infrastructure as a code, consider your end goal. All right? We all know that we want a running system. Is that the end goal? The company is not going to end the day after the system first runs. So I would say that's not your end goal. You're going to be changing the system. You're going to be developing the system. You're going to be adding features, going to be doing variations. And you need to keep it running. One of the early decisions you need to make, are you going to do a maintenance window every time you upgrade? Or are you going to have continuous uptime? It makes a very strong difference in terms of how you approach the problem, what concepts you express, and what you're creating. Think about that up front. It's very hard to change your mind between those two things at the end. It's possible, but it takes a lot more work. Some guiding philosophies that I found well in this. This is probably the most important thing. With infrastructure as code, you want to be declarative. You want to state, I have a web server, I have a database, I have an app server. You don't want to create them. You want to state their existence. The reason for this is procedural thinking. If you think about the process of doing these things, it actually makes it much more difficult to reason about what state is my infrastructure in. Because if I have a bunch of procedures to create my infrastructure, now what my infrastructure looks like depends on every procedure that ever ran. And did it fail? And how it failed? And what ran next? Whereas if I declare it as state, then it's very simple. Here's my state declaration. That's what my infrastructure looks like. And by the way, developers love procedures, and they seem to hate state. So this is always a tension when you're dealing with somebody who's primarily developed program code. They just want to write a shell script to do it. That's not the right way. Gets you started really fast, gets you in trouble really fast, does not get you to the end game. Procedures are, of course, ultimately necessary. Somewhere along the line, something has to install Nginx or whatever. But you should push this as far down in the process as possible. When you are writing your code, when you're describing your infrastructure, you should be declaring this is what it is. CloudFormation and Terraform are both tools that do this very well. You express things as state. There clearly are procedures under the covers. They mostly hide them from you. When you write your own procedures, which you inevitably will, they should be idempotent. So what is that? Idempotent means you run it twice, you get the same end state. In other words, your end state does not depend on the beginning state when you execute the procedure. An example would be ensure there's a web server, not create a web server. And you can run these procedures again and again and again. One situation I recently dealt with, we had a script to start up the application. That's great. There are 6 nodes. Let's run the script on every node. Well, we can't because it's already running on those 3. And if we do that, then it'll fail. So we need to rewrite it to ensure that it's running to achieve an end state. To make this very concrete, this is bad. I'm creating a database, I'm creating a web server, I'm adding that to DNS. Because if I run it again, I've created another database, another web server, and well, www is a unique resource, so I probably now have a conflict. Which stack does this point to? Which one did I run last? Better, ensure the database exists. So if it already exists, I do nothing. Great. Ensure the web server exists. If it already exists, likewise, do nothing. Ensure a DNS name. And then you get to something much better. Again, CloudFormation or Terraform. There is a database. There is a web server. There is a DNS entry. They have these relationships. Just do it. These tools, CloudFormation, Terraform, that class of tools, figures out what state you're currently in, what state you want to be in, and then executes the procedures to get from one to the other. Puppet also does this if you're looking at machine configuration. One thing I will mention is something that is very nice about these is these tools also know how to destroy your resources when you're done. Because if you spin up 20 test environments in a day and you don't destroy them, eventually the CFO is going to get very upset with you. Next key, make it modular. Modularity is something that's been very important for program code for many years for very good reasons. Program code has objects. If you're in an object-oriented world, has functions or procedures if you're in a procedural world. Infrastructure as code should also have some type of modularity. Makes it much easier to reuse. If I have my database module, I can use that in 3 different stacks. I don't have to rewrite it each time. It also means that it's very easy to modify. Oh my database now has to have port 3306 open. I changed the definition in one place. Now I've used it everywhere instead of going and manipulating different stacks. I get consistent definitions, so when I'm writing my support wiki, I can say this is a database server. We know what that looks like. Here's how a database server is. Not what is this particular flavor of database server today. Key to this is make your modules semantically meaningful, not functionally meaningful. Semantics are the concepts you use to think about this. If you think about it as a database, that's what you should declare. It's a database. Think about this as a user database, that's what you should be declaring, a user database. This allows you to think about what you want and just write it in code. Also makes it really easy to describe to other people how things work. What's infrastructure look like? This. Go read it. Right? If you want to know why I got there, look into the source control. It's just all there. Test and verify your infrastructure. Nobody just compiles a program and says already ship it. You need to make sure it works. Same with your infrastructure. You can't deliver an untested infrastructure. How do we test our infrastructure? You've got a monitoring system there, right? Probably already have one. Certainly going to need one when you end up. Well, guess what? Testing, specifically testing what is just the first part of monitoring. Is my database up? Is my app server work? Is my web server up? Testing does it do this thing? Does it do that thing? Is just the second part of monitoring. You're going to be doing both of those anyway. So now you've just entered the realm of test-driven development, which is what developers started really raving about starting about 15 years ago. Gee, I can write my tests first. And this lets me know when I'm done. If I sit down and I write, here's what I need to monitor, and I'm staring at a bunch of red lights on the screen, and I code, and the red light goes away and turns green, and I code some more, and another one turns green. When they're all green, I'm done. And incidentally, if I break something, something turns red, and I know about it. So test-driven development is a very efficient way of, again, reaching the end goal sooner. So this means your monitoring system is not one of the things you throw on after your infrastructure is up. It's not an afterthought to make sure it's still going. It's a forethought. It is, how am I going to measure this and monitor it throughout? Am I going too fast here? I know I'm zipping through a lot of things. Cool.
Quick question about
Yes, sir.
monitoring.
Yes.
I mean, obviously, AWS gives you some facilities for monitoring.
Yep.
Which personally have not yet found easy to use.
Yep.
And clearly you could write your own.
Yep.
Do you have any suggestions about third-party tools that might help there?
It's a very rich space. I've got some that I've used. This is a screenshot of Zymon, which is a very old one that I keep going back to because I can literally stamp it out as a Docker container in 10 seconds.
Zymon?
Yes. It is really, truly ancient technology, but it's very quick, and I like that green. Now, I can look at it and go, oh, green is good, move on with my life. I don't have to spend time configuring logic monitor or what have you. Prometheus also looks pretty good. Part of the key for me is I want to instantiate a separate monitoring system or separate section of my monitoring system for every environment that I create. So I've got my dev environment and a monitoring system for it, my test environment and a monitoring system for it, et cetera. So when you use third-party services, it's often harder to do that. So how do we organize our code? We've all heard of the full stack. It's very nice and zen and pretty. Usually ends up looking more like this. So I assert that full stack thinking is actually hazardous. It's not a good way to think about the problem. It's difficult to change post-deployment. I've got a stack. It's difficult to deal with cross-cutting concern. Hey, my Ubuntu now has a vulnerability. That cuts across all of my stacks. My networking needs to change. Different parts of the stack are often maintained by different people. This is very true in large organizations when you have a different group doing networking versus doing user management versus doing application servers. It's also true in a very small organization because people always know one thing better than another. So if you've got a 3-person team, one person may really know networking. Well, then probably should be doing that part, at least until you need to share knowledge so if they get hit by a bus, you can survive. So instead of stacks, the concept that I found useful are planes. I found a physical plane, a network plane, a persistence plane, service plane, application plane, and control plane. So ultimately, they're all going to be instances or Lambda functions or something like that. It's a difference in how you think about things and how you organize your code. I came up with this kind of looking at the OSI model, the network model, where one layer provides services to those above it, but you may have many different things built on a layer. It allows clear separation of responsibilities and concerns. This is my networking plane. It doesn't handle web servers, it handles networking. This is something I've been doing for about the last year that's been very useful. If you take this concept and go, yeah, but this thing should be in that plane, not in that plane, that's fine. In fact, email me and let me know because I'm interested in how this develops in the real world. So I think the concept is useful. I'm not attached to where and what plane you put a particular piece of functionality. Physical plane. It's usually provided by AWS or, well, today it's provided by AWS, and at another conference it might be provided by Google. It can be provided with a rack. I actually do have one company I work with that still has a rack of systems because they have tests that run 24/7 for 3 months at a time. So they've decided that's more cost effective than having an instance in AWS. They also have instances in AWS to burst for their functional tests. So they can run 500 tests in the next 20 minutes and be done with it. Either way, the concept is the same. I have a physical plane. Network plane, communication, it's usually where conceptually compute and storage live. Not necessarily, physically where they live, but that's how we usually think about them. Communication security, security groups, firewall rules, that type of thing, may or may not be part of your network plane, depending on your design, how you think about things. It's reasonable to think, when I deploy an application, I want to deploy the security groups that allows traffic in. It's also reasonable to say, nope, the network plane defines all that, the application is just going to use them. How do you think about the problem? Make your code match that. Persistence plane is an interesting one. It's a bit special. This is the only one that I don't burn down regularly. Everything else, I'll change it. Rip it all out, put it all back. Depending on my application, maybe that takes as much as an hour. Persistence plane holds the critical data. I cannot burn it down. If I burn it down, the company closes. Right? This is the place where you have backups, where you have any data you cannot recreate. And that's actually why I got into this plane model in the first place, is I realized, gee, I got this thing that really needs to be handled specially and really is different. And that started me looking at other differences. Services plane. Commonly available network services, DNS, maybe my VPN. Service location tools like Console, like etcd, like Amazon Route 53 internal zones. I consider all part of this plane. Secrets management, perhaps user auth. All the things that when you build your application, you assume these services are available. Databases. This is actually an interesting question. They might be part of the services plane. If you've got the concept that that's one of the services that I just deal with, then your database probably lives in your services plane. It also could be part of your application plane. If you consider, nope, the database is part of the application, it goes up and down and is upgraded with the application, then it's probably part of your application plane. It's almost certainly not part of your persistence plane unless you're really betting your whole company that the database will never go down and never be corrupted. If so, please tell me, please tell us all, because we want to short that company's stock.
So what's on your persistence plan if it's not a database?
Typically backups. If you're in a big data system where, practically speaking, the data is not recreatable because you could recreate it from backups, but it'll take 3 months, that's there as well. A database could theoretically get big enough that you have to treat it like a persistence plane object. If it's, I usually define big data as when somebody asks you for your copy, you laugh. That's when data is big. So if it's not practical to restore it, it's persistence plane.
Okay, where's your mainframe? What plane is that on?
I don't actually deal with mainframes much anymore. So I would actually be really interested in that conversation to find out, where does it fit in this model, or does the model need to change? This is about what I've found useful, and I'd love to hear more about what you think is useful. Yes, sir.
You said at the beginning of this that all applications should have all planes, or I can think of maybe an example where you wouldn't need a persistence plane. Is that?
I can think of those examples as well. These are the planes, the 6 planes that I've found common across a lot of applications. I can imagine that you might find another, particularly if you have a strong conceptual space that exists in your company of this type of thing, might be another plane. And yeah, there are definitely some where you don't have that plane. Some applications are so simple they don't need a control plane, and persistence plane is obviously irrelevant for a purely functional application. Application plane, probably don't need to say a whole lot about it. This is the place that actually touches the users. I will say that when you're dealing with the application plane, with planes in general, they may modify the state of a previous plane. So my service location, console, might be on the services plane. When I deploy an application, it puts a value into console saying this is where the application lives. So it's not like the planes are ivory towers that never talk. They are built on each other. It's more, this plane has this responsibility and this authority. Other planes use it and rely on it to fulfill those responsibilities. Control plane. This is the one that the users never see unless it's not working. This is where you might have your backups, schedule batch jobs. If you need to modify users, you have some procedure or job that does that. I often put my infrastructure rollout here because I'll roll this out in an automated fashion. I'll say more about that in a little bit. And of course, recovery. If something goes wrong, that's a control plane activity. Cloud systems often provide this. For example, scale. Today I have 6 servers. Black Friday I will have 24 servers. That's a control plane activity to change that scale. And clearly Amazon's going to provide part of that with a auto-scaling grid. Getting into some more practical details, definitely going from the outside into the middle of the onion here. Some musts for this. You must have a separate, isolated, no-risk infrastructure development area. Can't be production. And this is a must because it allows you to develop much faster. You've got to be able to try things out and take chances that don't break your users. You must have a way to verify, to find out if you got it right. You can't just say, guess I'm running a server. Maybe it'll work. And you must use a source control tool because this infrastructure is code. This changes over time. That's important for so many reasons that I could spend 20 minutes talking about them and I won't. You must not develop in production. Yeah, everybody knows this. But can you just make this one little change real quick for me, please? Guess what? You're now developing in production. If your process is good, you can make the one little change and you don't have to do it in production. You can get it out and satisfy your users, your company's needs. People say, can you make this one little change in production when you've actually built this thing that slows everybody down, and they don't want to be slowed down. So it's a continual tuning process here. Should. These are not as strong as musts. I found these are really good ideas. If you don't do them, they cost you, but they're not strictly necessary. You should have an automated rollout process. Now, this is not every time somebody checks in, it gets rolled out to production. This is, we need some form of rollout process that you don't have to manually type things. At most, your interaction with is, yes, I approve this to go forward. I'm promoting this to the next level. You also should frequently set things up from scratch, from blank, from nothing exists, bring it up. That's what you're doing with your DR environment. If you don't do this, you don't actually know, does my current infrastructure as code actually describe my infrastructure, or does it actually rely on some previous state? I've accidentally snuck in something procedural, and that's going to cause me a problem. You should not develop even near production. If the same set of credentials that are rolling out your dev environment can mess up your production environment, you could have a problem. So build in safeties. And the idea here is you want to be confident, I can try this out. I'm not going to break anything. You want to be on the enthusiasm side of that, not the pessimism side of that. You should not have manual steps. As the last keynote speaker was saying about a little bit of server and serverless has impact way out of proportion. It's the same with manual steps and infrastructure as code. It means you can't roll out as quickly, you can't be as sure of it. You never know, did you forget it, did you do it right? Well, yeah, this time I did, but at 3 in the morning when I was trying to set something up, I may not have. Again, impact way out of proportion to just a little bit of manual. I keep repeating this because it's very important. Write the way you think. We think about infrastructure as objects. There's a network, there's a server, Here's a load balancer. It has these instances. We don't think about them as procedures. That's what we do to achieve our state. So our tools should work the same way. Definitely been into several places where, do you have automation? Sure. Here's a bash script. It calls the AWS command line. Ooh, okay, well, it's better than nothing. Component dependencies. You've often heard this. Just make sure the database is up before the app, right? No problem. Can handle that. Oh, right. And auth needs to be up before the web farm is up. All right, well, there's the second one. Oh, yeah, and logging needs to, yeah. This way lies madness. More importantly, failures cascade in this. As the database goes down, everything downstream of it goes down. We all know this. Recovery doesn't cascade. I get one failure causing a whole bunch of problems, and now I'm running around like mad restarting processes to bring them back up in the right order. This is not a great way to scale a process and stay sane. What we want is cascading recovery. We achieve that by building health checks, and we have our pieces retry and wait. Database is enough. All right, I'll wait a few seconds to try again, and keep doing that and keep doing that. Gives you a much more scalable process, gives you better recovery time. I fix the problem, and then I step back and watch it recover. It gives me the self-healing. I'm usually asleep at 3 a.m. Actually, I've usually just gone to bed not too long before that. So if I'm woken up to deal with a problem at 3 a.m., I'm probably not as sharp as I could be. So I want to make it as easy on myself as possible. So what if we don't have this? Wrap the component. Don't be afraid to write your own wrapper around something that a developer gives you or the third party gives you. I've run a Jira stack. Jira is wonderful. It loses connection to the database. It puts up an error page on the web page. It puts a message in the log file, and the process keeps running. So now I wrap this in something that examines the log file, says, oh, look, it's lost connection to a database, restart it. So now I have created a tool that will wait and retry for its dependency out of a tool that does not. Service discovery, very important function in infrastructure as code, console, etcd, DNS. Keep it as close to your stack as possible. So you don't want global names in DNS locating your database for you. Keep the service names as unchanged as possible. So my app server knows I'm talking to the database. And in dev, that's a different database than in prod. But the app server just says, I'm database. That way I don't have to configure as much. I don't have to change configuration in the different environments. I can change my infrastructure, not my configuration. Bind external services as late as possible. This is something we've been doing for a while with like blue-green deployments. We point the public traffic to a stack late in the game, not early. So you don't want to, say, put up your production stack and have it automatically start grabbing traffic. That should be a separate step and as late as you can do it. When you write the code itself, use inspection instead of passing variables between planes. It's a great idea to use modules and pass in parameters to modules, but when you start dividing planes, you don't want, CloudFormation has a way to have outputs that you have to import into another stack. It works, it's painful. Terraform has a way you can actually look up resources. That works much better. However, pass variables instead of hard coding things. You don't want to know VPC-12345 is my VPC. You'd rather get that out of the CloudFormation output. Comment your code. This is something that ops people have no long history of doing, so I'm emphasizing it. Write comments. Yes, sir.
Can you say a little bit more about what you mean by inspection versus a variable path? I'm not quite sure I understand what you mean by inspection.
Yep. So with Terraform, for example, if I want to find a VPC that already exists, I have a construct that says, find me the VPC tagged production, or tagged production for app foo. and I get that as an object I can deal with. What I don't have to do is say, like in CloudFormation, go to the production stack, read its outputs, take the VPC ID. So it's an easier way of dealing with things. When you comment your code, talk about why you're doing things, not how you're doing them. The how should be obvious in the tool. Use good commit messages because you're writing code now and you're developing a history. This is where all the lessons that developers have done for years completely apply. Rolling things out. When you've got a change you think is ready to go, prove it by rolling it out in a lower risk environment first. Your developers are almost always more friendly than your customers to downtime. So if you're going to break something, break your devs, not your customers. Start with dev. QA is probably a little bit less friendly than development. Staging environment, as I found, is a good idea. If, nope, this is exactly like production, except it's not production. And then you get into the details of a blue-green or a canary deployment, however you want to do that. It's a lot of environments to manage, but it's not a problem because we have infrastructure as code. We're not managing these environments manually. That's the point of them. I do like canaries, if possible. Canary is where you bleed a little bit of traffic onto a new system to verify that it works. It's not something you can do in that one server handling 1 or 2 transactions per second. It's a lot easier to do at 14,000 transactions per second. Roll back versus roll forward. I've seen things work both ways. Make a decision and stick with it. Roll forward is, oh, something broke. How do I fix it? I code up a fix and apply it. Roll back is, oh, something broke. Go back to the previous version and use that instead. If you are rolling forward, you need to make sure you can roll forward to a previously working component. So if like you've changed your Ubuntu version, make sure you can now change it to the working version again if you can't exactly go back. I could talk a lot about rollback. The short form is it's not real in almost all systems. They fake it. Sometimes they fake it really well. Control plane controls the behavior of the other planes. Backups, remove users, batch jobs, things like that. A little bit about scheduling. Cron is evil. All right, so it's not really evil, but if you've got cron running on 200 systems, it's hard to monitor, it's hard to change, it's hard to see what it's doing. Requires a system administrator to do that. So it's much better to have like a single pane that executes your thing. I happen to use Jenkins, which is traditionally a build tool. It also works really well as a remote management tool if you're willing to pay the overhead of Java. There are plenty of other tools out there that do this. Put things in one of those tools instead of cron. Runbooks, not a concept I actually encountered until I got into the operations side. Here's my statement about runbooks. Sufficiently detailed documentation is executable. If you've really documented well enough, it's a script you can just run. Therefore, anything you do regularly should be scripted. So that's just a runbook. Failure recovery should be as automated as you possibly can. I don't like downtime. I have a serious allergy to downtime. Trying to figure things out on the fly is difficult. It's much easier to have that script you can run. So what's left after you've scripted as much as you can is troubleshooting and problems you don't yet know exist. And that's very difficult to runbook. So the upshot of this is I don't have a lot of use for runbooks, which are basically code for human computers. I'd rather make code for an electronic computer and know it's repeatable. Tie this all together. Here's my high points. Describe your infrastructure as code as declaratively as you possibly can. Develop it in a separate location from your production. Organize it into planes of responsibility so you don't mix too much responsibility in one place. Make it modular. Build it out of your Legos. Deploy your changes across your environment, not all at once. and automate all of your normal operations. Then you may actually be able to take a vacation. If anyone's interested, all the pictures were actually labeled for reuse, and there are the links. Questions? Yes, sir. Yes. They have all I'm not sure what source. You can also Google me. I have a fairly unique name, and it's available on my website. Yes, sir.
All kinds of continuous deployment seems at odds with what you're describing about doing your things in isolated environments.
Oh, no, not at all.
More about that.
So one system I set up, as soon as somebody checked in some code, it got put into a test environment. The role of that test environment was to verify for the developers that what they did worked. Then somebody would click a button that says, yes, I agree that this works. Mostly that button click was because I wanted the accountability that someone had examined the test cases, examined the monitoring system, and said, yes, this does adequately test what we've done. And then they can promote it. As soon as it did that, it went to a effectively QA system. We called it a demo system. This was as live as possible without actually modifying production code. So I could point my, in this case, web tools, I could point my browser at production, or I could point my browser at this demo system and exercise everything, but it wouldn't actually commit anything to production. And then when we approved that, then it automatically went to production. So I look at this as CI/CD. It doesn't happen completely automagically because we did not build a system that could be fully automatically tested. But there was an automated system doing all these things, and what the humans were doing was making the decisions about it, not doing the work. Yes?
With the ability to spin up infrastructure, essentially, through use of API and service options, what are your thoughts on pushing some or all of DevOps responsibilities to the particular, well-rounded development teams, having them all everything?
I love it. I've seen it work very well, particularly when developers are woken up at 3 in the morning. Stuff gets fixed amazingly quickly. And key to that is you put the pain point with the person who has the power to fix it. So if the pain is occurring in a program that developers develop, yeah, great, make them feel it. If the pain is deploying something I'm responsible for, make me feel it, and I'll fix it. In that particular environment, my role was mainly consulting and guidance, and they would come up with, how do we do this? And then I would also maintain common components, like the monitoring system. They weren't interested in doing the monitoring system, so I did the monitoring system, said, here's how you hook it up to it. Now here's your stats-D, go into here, we're all set. And that worked out very well. I've also found developers who have no clue of operational concepts, and I really can't do that with. You had a question, sir?
I did, and now I've forgotten the name of the tool, Terraform.
Terraform.
Never used Terraform before, but I've heard it talked about a lot in several things I've gone to in the last few weeks. If we have a very simple environment, is there a steep learning curve for Terraform? Is it worth doing for a very simple environment?
I have found that it is, and it's not a particularly steep learning curve.
Okay.
The majority of the learning curve for most people is getting used to declarative rather than procedural. Once you've overcome that, Terraform's actually a pretty straightforward syntax, and there are IDEs to help you compose it, and it works pretty well.
Okay, great.
Yes, sir.
Yeah. What do you prefer putting your code in terms of infrastructure as code? If you're defining infrastructure as a support an application, do you put it with the application, or do you put it somewhere?
I typically don't, because the code the same infrastructure may deploy different versions of the application, or I may evolve the infrastructure several times to deploy the same application. So mostly that's a matter of, I want to identify a particular set of unique bits as this is the thing I'm running. And separating out this is the application from this is the infrastructure helps. I also will often have infrastructure that pulls from very many different applications or deploys different applications into the same environment. And so there's really no one place to put it. I have to put it in a separate place there. And last question, I think.
You spoke to environment, you mentioned Terraform, do you see a use case for a Puppet or Chef or Ansible kind of traditional distribution tools?
Yes. Ansible, disclaimer, I haven't used Ansible as a primary tool ever, but it strikes me as a much, much better SSH that you can really well automate. That I don't have a lot of use for because, yes, it can have some impact at the control plane, but it's not primary tool. I've also seen Ansible used for configuration as Chef and Puppet do. Sure, whatever tool works best for you, use it there. I do not mix machine configuration with infrastructure declaration. So Terraform doesn't configure machines. It provisions them, creates them, and then calls one of these other tools that was created to configure machines, like Puppet or Chef. That's a good separation of concerns. Now, I also have dealt with machines where the configuration was so simple, notably if you're running containers on a very thin OS like CoreOS, there's really no machine configuration. So you just instantiate a machine, put some containers on it, and you're done. There is no role for Chef or Puppet there. All right, we're out of time, so I'll be around, be happy to talk about this more with you, and thank you very much.